Okay, so today this lesson is about the area of a regular polygon. And for today's lesson, I have a pentagon here that I'm going to be talking about. And I just want to use that as an example. And so some things that we're going to I need for you to know about, first of all, is if you start at the center of any polygon and go straight down to the side length at a right angle, that length there is called an apothem. Okay, so now what we're going to do is we're going to take our pentagon and divide it up into chunks. Okay, so what I have here is I have 5 triangles, and all these triangles are equal in size. They're all congruent triangles, and there are 5 of them because it is a pentagon, right? There are 5 sides, so therefore there are going to be 5 triangles. So if we talk about the area of one of those triangles, we're going to get 1/2 base times height. Well, in this case, the base is the side length of the pentagon, and the height, in this case of this triangle, is the apothem. Okay, so once again, the area of this triangle is 1/2 base, which is a side length of the whole pentagon, and height, which is the apothem. So now what we're going to do is talk about the area of a polygon. So the area of the polygon is one of these triangles times how many triangles there are. In this case, there are 5. If this was a hexagon, it would be 6. If this was an octagon, there would be 8. So what we're going to do is we're going to take the area of one of the triangles and multiply it by how many sides there are. And I'm going to use n for how many sides there are. So once again, 1/2 side length times apothem times how many sides of the polygon we have. So if you remember, multiplication is commutative, so you can kind of flip things around a little bit. So I flipped around my n and my a so that I have my side length and my n together. Now, what does side length times how many sides there are tell you? Well, that's going to be the perimeter. So what we have then is that the area of a polygon is going to be 1/2 perimeter times apothem. And usually you see that in the book as 1/2 apothem times perimeter. They usually flip it around a little bit. So there's my area of a polygon. Area equals 1/2 times apothem times perimeter. And so let's go ahead and put that to use. So here we have our first problem. We're going to find the area of a regular polygon and round to the nearest tenth. And what they want us to do is find a hexagon. Hexagon, remember, has 6 sides with a side length of 6 meters. So there's my hexagon. I have a side length of 6 meters. The first thing I'm going to do is draw on my apothem here. And I want to talk about this triangle right there. Now, you don't always have to draw the picture of the polygon. Once you get used to doing this, then you'll only be focusing on this little triangle right there. In fact, that's going to be step 1, which I'm going to write next. So step 1, we're going to draw the triangle from the polygon. So what I'm going to do is draw this triangle right here separately, and I'm just going to draw it out right down here. So here's my triangle from the polygon, and the length down here is half the side length that I'm given. I'm told that the whole side length is 6, so that means that this is going to be 3. My apothem I don't know, so I'm just going to write an A there. And this degree right here, if the whole degree was 360 divided by the side length, which we learned on the previous slide, then this degree right here is going to be only 180 divided by the number of sides because it's only half the size. So we get the degree to be 180 divided by 6, which is 30 degrees, okay? So now what we're going to do is use trigonometry. Now this happens to be a 30, 60, 90 triangle, so you can instead use what you know about 30, 60, 90 triangles, but just to be consistent, I'm going to go ahead and use trig instead. So if you're not sure about how to use trig, you need to watch another lesson about trigonometry. But what I'm going to do is I'm going to circle my angle I'm working from, label my sides. I've got my opposite here, and I've got my adjacent here. And so that's going to be tan. So we have tan of the angle 30 equals opposite, which is 3 over A, which is my adjacent side, which also happens to be the apothem. So now we know then that A equals 3 divided by tan of 30. So step 2 was to use trigonometry to find out what we need to know. In this case, we needed to know the apothem, so that's what we use trig to find out. Step 3 is to plug your formula in and to solve with a calculator. So our area is 1/2 apothem. My apothem is 3 divided by tan of 30 times perimeter. So my side length is 6. So that means my perimeter is going to be 6 times 6. And now I can go ahead and use my calculator. It's kind of important that you know how to use a calculator. If you have a large screen calculator, then you can plug it in exactly as you see here. If you have a small, and make sure that you put in your parentheses, by the way, because that will help. If you have a small screen calculator, what you're going to want to do is start in and work your way out. So if you have a small screen calculator, you're going to want to do 3 divided by tan of 30 equals, multiply by 0.5, multiply by 36. So go ahead and take your calculators out and pause this video and practice right now. So when you use your calculator, you're going to find out that you should get 93.53. If you did not get 93.53, check first of all to make sure you're plugging it in correctly, and then also make sure that your calculator is set to using degrees and not radians or gradients, because that sometimes will mess you up as well. Okay? So that's how to use the formula to find the area of a polygon. Thanks for watching.